Good evening. Actually, unfortunately, we don't have any live participants, but whomsoever watching this recording. So, good evening. And last two lecture I pre-recorded and then upload. So, because I was not in the India and I was traveling abroad, but now I am back to India, so I will take all the live session in the live mode only. So today this is the week 4 discussion of mechanical unit operation course, and now uh, I want to share my screen. So okay, I can't able to ask anyone get I am audible or not, but hope so I am audible. So I'm start sharing my screen. Okay, so okay, this is today's discussion about mechanical unit operation week 4, and now uh, we start our discussion. Wait, yeah, okay. So today in the week 4, mainly major topic covered is storage and conveying of bulk solids. Now we need to understand, we already understand how to screen the solids, how the size reduction operations are going on, but now the main focus is on the after all the operation will be completed, now whatever the final product which will be there in the solid form, how can we store that product and how can we transport that product from one place to another place. That is the main idea behind today's discussion. And as you can see in this today's that week 4 assignment, many of the conceptual questions were there. So now we that's why we also wanted to discuss more in the perspective of the concept of how the designing of this storage and conveying of taking place. Okay, so I think someone has joined. Okay, so uh, today we discuss about the storage and conveying of bulk solids, and as you can see that more of the assignment problems are discussing about the design of the storage and conveying medium. So we will go for the theoretical part as well as we trying to solve some simple example which was mentioned in the assignments. It's a similar kind of example which is there in the assignment. We start with the storage of the bulk solids, solid flow out and their flow patterns. All are I am only covering the topics. I am not covering all the topics which is covered by the professors. I am only touching up the topics which from which assignment questions are there, conveying of the bulk solids. Now, so this is outline of our today's discussion. We start with what are the basic properties of masses of particles. How can we store the solids, bulk as the bulk medium or is in the bean medium? What is the pressure which is there in this kind of different mediums of storage? What are the different patterns when we flow the solid from one equipment to another or from one part to the another part? Then conveying, obviously, then power calculation, what are the equations, and then some examples. So first we start with the properties. So properties of masses of particles. As you can see that if we discuss about the properties of fluid, then it is totally different than the properties of the solid. So when we think about the dry and non-sticky particles of solids, then they have many properties of fluid, like exert pressures on the side and walls of the containers. If we are dealing with the dry and non-sticky solids, then there are chances that that pressure will be exerted on the side and walls of the container. It can be flow through opening. Now, masses of particle also differ from liquid and gases in several ways. Obviously, fluid have their own way to transport from one place to another, their own way of property to display of the property to exert the pressure and motion calculation on it. But if we talk about the solids, then particles interlock under pressure and cannot slide over one another until applied force which is an appreciable magnitude. So it's not like that fluid which we apply the pressure and they start flow So that is the definition of the fluid, right? But if we talk about the solids, then it is not the case. They are interlocked with each other, and we need to apply the pressure of some threshold limit. After that only it can start to flow, or it can start to move accordingly. Now, granular solid and solid masses permanently resist distortion when subject to a moderate distorting force. So, if you are talking about the granular solids, which has a granules form, or some different kind of shape, which has a solid masses which has shape, they permanently resist distortion. Distortion, you can say about the stress or some force you applied to a moderate distorting force. It cannot sustain a large amount of force, but for a moderate amount of force it can permanently resist that distortion. Why I am going for the theoretical? Because it is required to understand some of the assignment questions. When applied force is large, failure occurs and one layer of particles slide over another, but between layer on each side of the failure there is appreciable friction. As we know about the fluid, say if we talk about the viscosity, then one layer is flow to the another fluid layer, and there in between they have viscosity, so which is nothing but friction only. If we talk about the slides of the particle, then it is the same phenomena, but in between they have friction force. Okay, hope so you can able to understand the things. So that's why layer between the layers failure is appreciable because of friction. Now we have to discuss about the distinctive properties of the solid masses. So distinctive in the sense of this distinctive from the fluid, which is different from the fluid. So pressure is not same in all direction. It's not same like the fluid. Pressure applied in one direction creates some pressure in another direction, but it is always smaller than applied pressure. As you can understand, if you apply some pressure over here, in this is a solid mass, then there may be some pressure which is applied in other direction, but it is always if you can say FA or PA, or this is a PB, then PA is always less than PB. It is minimum in the direction at right angles to the applied pressure. So if you have any pressure in this direction, if you apply pressure like this and any pressure is there, it is minimum. So these are the property we need to understand when we are talking about some calculation based on the solid mass transport. In homogeneous masses, the ratio of the normal pressure to the applied pressure is constant K. So this is a very important definition. There is one constant which we consider as a K, which is which depends on the characteristics of the material. All materials have the different values of K, but it is basically the normal pressure to the applied pressure. So you can consider the ratio of normal pressure to the applied pressure, and there are many questions on base of this. Based on this K in your assignment problem. Now this constant depends on the shape and interlocking tendencies of particles, on stickiness of particle surface, and how tightly the material is packed. So you can consider that depends on the behavior and apertures and different kinds of configurations of properties, or with some physical properties. This value depends on them. So this constant is nearly independent of particle size until the grains become very small. The material is no longer free flowing. So that's, you have to understand that K is always independent of particle size, whether you are dealing with the large particle or the small particle. But if you talk about the very very fine particle, which is in the micron, or you are talking about a nanoparticle, then you need to consider that particle size is also depend. This constant is also depend on the particle size. It varies according to the particle size. Now shear stress applied at the surface of a solid mass of particle is transmitted throughout the static mass of particle unless failure occurs. So whatever amount of shear stress you applied at the surface of a solid mass of particle is transmitted throughout the static mass of particle. So whatever if there are some particles are there and you applied the shear stress like this, then it is transmitted to static mass only, and some failure occurs, then it will be converted into the motion. So this is all about the language of the book, so I don't want to change anything from that. So I am taking the lecture notes of professor to understand all this concept. But you need to understand the value of k, which is what is it and how, what is the significance of the k, which is nothing but the normal pressure divided by applied pressure. That means, so whatever amount of pressure you apply, as high you apply the pressure, the value of k will be lower down. So from that you can consider the if your material is value of k is high, then your applied pressure is too low. If you applied low pressure, then also normal pressure will be high. So there are many interpretation you can take from that. Now, density of solid masses vary depending on degree of packing of grains. So as you can understand, packing of grains is totally different. If material is totally sphere, then the packing is like that. If it has some different shape, then there will be not much packing, or if you have some uniform shape, then the packing is different. So that's why density of solid mass is also depending on this kind of degree of packing of grains. Now, for a mass of tightly packed particles to flow, so this is one phenomena where it is mentioned that if we have tightly packed particles which is totally packed with each other, interlock with each other, if you want to flow them, then we need to consider this thing, that it must increase in volume to permit interlocking grains to move past one another. As we understand that if it is tightly packed, then the grains or solid particles are interlocking with each other, so it must increase the volume so that interlocking must be converted into the motion. Without such dilation, flow is not possible. So for flowing, we require some increment in the volume, and some you can consider that some threshold volume required to pass over that. Now, sides of granular solid piled upon a flat surface are at a definite reproducible angle with the horizontal. So this angle is called as the angle of repose. As you can consider, as you can know, if we pour the solid, then it is pouring like this. So it is making some angle with our what you can say floor, or some angle with our horizontal surface. So this angle is also vary depending on which solid you are using. So for free, or there is a question that for free flowing granular solid, what is the value of this angle of repose? So you can, if you have any question is like that, so you can consider this value 15 to 30 degrees. It's always like that, but all different kind of solid have different kind of angles. You need to consider that thing. Solid masses are classified as a cohesive particle and non-cohesive particle depending on the flow properties. As we know that solid particle also has a cohesion force in between, when two are attracted with each other with the help of cohesive forces. So if our particles are like that, which is attracted by cohesive forces, then there are different kind of flow properties and classification. If they are non-cohesive, then there is different flow properties. Now, if these are some example of the cohesive force solid particles. So wet clay, highly concentrated slurries, as anything is wet or not dry, you can consider as a cohesive. Or most of the time wet particles are incohesive in the nature. They are reluctant to flow, because you can understand, if the clay is dry, then you can easily, like in the sand form, you can easily flow it. It can easily flow, but if it is in a very sticky form and wet form, then it is very difficult to flow through openings, and the K value it tends to 0. So normal pressure divided by applied pressure, so it is the K value. So K value tends to 0, that means normal pressure tends to 0. So that's why whatever amount of pressure you applied, it is not able to flow, or the solid cannot able to flow by using this amount of pressure up to some threshold value. And if you talk about non-cohesive particles, which is dry particles, some grain, plastic chips, which has the K value, it ranges between 0.35 to 0.6. If any questions is there in the exam or an assignment of the K value of non-cohesive and cohesive particle, you should have understand the physical significance as well as the value of K for them. Now storage of solids. Now this is we just discuss about what kind of properties of which solid exerts. Now we want to store them and we want to transport them. That is our main objective, storage and transportation. That is our objective of this total whole week discussion. So from that we need to understand first properties. So we already gone through the property in more detail. You can revisit professor's section. But for the transportation we will see in future upcoming slides. But for the storage there may be two different kind of storage which we need to understand. One is the bulk storage, another is a bin storage. So in bulk storage, many solid masses which are coarse materials such as a coal particle or stored outside, they are stored outside in the large piles without any protection from weather. The bulk storage, as you can store it in the bulk form, and in the bulk form you are not considering the protection of weather, because some particles are not, as you can see in the India, if you transport coal from one place to another using this railway, then there you can understand that always they use this open wagons, they are not closing sometimes. So for the coals particle it is fine, and such type of outdoor storage is very economical. Obviously we don't need to go for some specific kind of design, we don't need to take care of protection from weather, environment, oxidizing of the particles and all. So that's why we can save many amount of our economical expenditure over that. And when 100,000 of tons of material we need to transfer, we are going for this kind of bulk storage. Now if on a requirement, this bulk storage are removed from the piles by dragline or tractor and delivered to conveyor. It's a very easy to transfer from one place to another if we want to store it into the bulk form. Such outdoor storage lead to environmental problems. Definitely, when we store coal into some wagons like this, it's in train, it dust particles and all are going to environment. Not much, but obviously in the small amount it will go into the environment. So definitely it will create some problems. Dusting can be overcome obviously. So we need to overcome the dusting. Leaching can be controlled. These are the some parameters we need to understand when we are storing the materials like this. Now another one is the bin storage. Okay, so bin storage is a valuable or two soluble solids are there. If you talk about some very rare earth metal or some part, then you can go for this bin storage. And then in bin storage also, it's or in process plants, if you want to store the material in between, then you have to go for this bin kind of storage. These are cylindrical. There are mainly bins, hoppers or silos. These are cylindrical rectangular vessels of concrete or metal. These are some fundamental physical properties of bin storage. Silo is tall and relatively small in diameter. Bin is not very tall and usually fairly wide. So you can consider if you consider the silos. Silo has this very less diameter and very tall in nature. Height is very much high. But if you talk about the bin, then bins are like this. Their diameter is wide and they are not very tall. Hopper is a small vessel with a sloping bottom. So if you talk about the hopper, then hopper it's always used in the interconnection between two different processes, or you can say the temporary storage between the two processes or before the feeding to a process. And bin silos and hoppers are loaded from top by kind of elevators, and discharging is generally done from the bottom. So this is a common for the bin silos or hoppers, which is a bin storage. So as you can see, this is one kind of bins, or you can say silos. Their axis symmetric flow is there. Flow is always follow the axis and it is symmetric. But here is because it's a cylindrical. As you can see, the shape is a cylindric silo. We talk about the symmetrical plane, then there are different planes are there, and you consider that symmetry is perfect. so the flow will be in the form of symmetry. But sometimes if you are not following the symmetry, then this kind of options are there that no symmetrical plane. But the other all have their own advantages and disadvantages according to our use and application. We can choose any of them. Now pressures in bins and silos. Now we can't just store the materials and understand that what is the requirement, or we can just fulfill our requirement and we don't need to bother more thing than that. We need to understand what is the pressure, how it is exerts, how it can resist our flow of the material. So all these things we need to understand. That's why pressures in bins and silos are the one and discussion which professor discussed very well, and we just go through some of the major points of it. So lateral pressure exerted on walls at any point is less than predicted pressure from the head of the material above that point. So you need to understand that on the walls, if any pressure is there, then it is always less than the predicted pressure from the head of the material. Okay, so whatever you are lateral pressure exerted, what you apply the pressure. So and if you predict the some pressure which is there, then it is always less than that exerted pressure is less. Now friction between wall and solid grains. So okay, so when you are talking about the pressure on bins and silos, so you need to understand what is the friction is there for wall in between the wall and solid grain. This friction is felt throughout the mass because of interlocking of the particle. Okay, so particle has properties, solid particle has the property which is different from the fluid particle, and they are interlocking with each other, and if you apply the pressure, then it will generate the friction, and that friction is also interlocking due to interlocking of the particle, it is also felt everywhere. Now vertical pressure on vessel floor or the packing support is much smaller than the exerted by the column of liquid of same density and height. So if you talk about the vertical pressure, which is, if you talk about the fluid pressure, of pressure exerted by the fluid or some liquid, and pressure exerted by the solids, that the pressure is on the support is smaller than that is exerted by the column of liquid of the same density and height. Now this is important thing, that actual pressure from the solid depends on, now what is depending factor of our actual pressure, then it is always depend on the value of the K for respective solid. What is the friction coefficient between the solid and container wall, the way solids are placed in the vessel. These all three things we need to understand whenever we are talking about the pressure which is exerted in bins and silos for the storing of our materials. So this is all things we require when we are designing this kind of bins and silos. So that's why we need to understand the properties, we need to understand the pressures, exertion, we need to understand the ways to store the material. Now if height of a solid column greater than 3 times diameters of container, so if we talk about the our solid column has a column like this which has the height, sorry I can't able to draw something very good in this PowerPoint presentation slide. So if height of the solid column greater than 3 times, then additional solid have no effect on pressure at the base. So if we are putting the additional solid, only some amount of solid only has a pressure exertion at the base, additional doesn't have any effect. However, total mass increases more solids are added. Obviously, if you are adding the solid up to here, then mass will be increases and so on. And that, but although they don't have any effect on the what you can say the pressure which is exerting on the base. Unlike in the case of liquids, for granular solid, high pressure does not increase the tendency to flow. So in liquid, if you are applying the high pressure, then it increases the flow rate, increases the tendency of the flow. But here it is not the case. If you apply the high pressure, then also it is not differentiating any property of solid particle. Combination of friction and gravitational force at some point in the container causes solid to bridge in some extreme cases, so that they do not fall even when the material below them is in. So for the consideration, we need to understand what is the pressure forces and different forces, force balance. We need to consider at that time. So it can causes solid to freeze in some extreme cases, where it can stagnate in some extreme cases. But after they can't even fall also when the material below them is also removed. Suppose here some material is got breach or stuck or there. If you remove the material which is below than that, then also it remains stuck. So granular solid with angular particle must be loose in order to flow. So if you are dealing with granular solid and it has angular particles, so it needs to be loose if you want to flow them. Now this is discuss from the second lecture of the professor on what are the important thing and what from why we are discussing all this theoretical part, because there are questions in the assignments and I am only picking the topics which has some there are questions which is based on the some topics and I am taking the topic and we just revisited the discussion. So that's why you can find more details just reading about that topic and you can easily solve the assignment. That is the whole purpose of taking this kind of some theoretical topic in between the examples, because this whole is more theoretical exercise than assignment of to this week then the example ones. So solid flow out and their flow pattern. So how the solid will flow out from their flow patterns. So solid can flow out. There can be flow out from the side opening, as you can see if you just draw. So there can be flow out from the side opening. They can be flow out from the bottom. The bottom outlets are there. Then what are the types of flow out? A solid can flow out from here also. It's overflow you can consider. Now types of flow patterns. So basically there are three types of flow pattern possible in symmetrical geometry. We just consider the symmetrical geometry. We are not considering the asymmetrical geometry. One is based on the mass flow patterns. Another is a funnel or tunnel flow pattern. So with these two are important in order to your examination assignment questions. And third is the expanded flow. So we will visit this mass flow and funnel flow and some interesting characteristics of both the kind of flow. So first is the mass flow pattern. So as you can understand, mass flow pattern is depend on the mass of the particle. So it is a common in hoppers of sufficiently steep, that is cone bottom means with tall and steep cone and smooth surface. So if you have a hopper which has steep surface, then your mass flow pattern can be easily visible. And what are the characteristics? The mass flow can cause flow of solid in the bin without stagnant regions and during the discharge. So it is a very advantageous property that it can flow of solid without any stagnant regions generation in the storage. Solids are in motion in every point within the bin whenever material is drawn from outlet. Whenever we are material drawn from outlet, of which whether it is bottom or at the side, the solid is always in the motion. Flow is always uniform. Bulk density of solid is independent of the head of the solids. So always density is independent. So this is the only you can consider that when you are using some dry powder, dry material, then this kind of mass flow pattern can be generated. And as you can see here that in mass flow pattern, it's smoothly flow from upwards to downward. There are no any stagnation and easily flow is there. And you can consider the different characteristics when you want to design this kind of mass flow pattern based on equipment. So there is one is the D diameter. You need to understand what is the average depth of material when material will be filled up to the what is the average depth. SCR is the critical depth to initiate the flow in mass flow. So this some height we need to consider. Above that height only the mass flow needs to be generated. If you put the material below the critical height, critical depth, then there will be no mass flow. Then there are some stagnant region is there. Hopper slope. So your hopper has some slope with the vertical axis. You need to consider what is the theta angle of that, and bottom aperture opening. All these things you need to understand in order to design the equipment like silos or some hopper to use mass flow pattern to transport your solid. Now mass flow bins are suitable for cohesive material, as we discussed that cohesive material is very difficult to transport. If you use the mass flow pattern, then it is very you can say techno-economically suitable for transporting them. Then material which degrade with time, we have to use this mass flow so that's why not stagnant region, they will not stay for a longer amount of time. Fine powder and particles which are required to be prevented from segregation. We want to require this prevention of segregation or the coagulation of the particle, then we need to go for mass flow patterns. Now as we discussed earlier also, if you want to go for mass flow pattern, then depending on the hopper shape and associated flow pattern, the mass flow bins are classified as a three different kind of bins, as we discussed earlier also. One is the axis symmetric flow. One can be used this cylindrical kind of nature of instrument equipment which can use for the axis symmetric flow. Another one is like this plane structure based on the symmetrical plane or non-symmetrical plane, which is wedge or chisel shape bins, and in plane flow bins. Now slope to the vertical of hopper is 8 to 10 degree larger than the corresponding value of axis symmetric bins with conical hoppers. So when you are talking about the vertical hopper, then slope is 8 to 10 degree larger than the value of axis symmetric bins, so it's conical hoppers. Thus it offers extra storage capacity than axis symmetric bins for the same surface. So it is one thing why we have to move towards these axis symmetric bins. What you can say is a vertical hopper means then axis symmetric bins. Now the another is a funnel flow pattern. This two flow pattern has some question in the assignments, and they are very important in your exam also. If any question asked from this flow pattern, then you need to differentiate them from the other parts of your subject, and you need to take care of the solution of the problem. So funnel flow pattern, it occurs when hopper is not sufficiently deep, not smooth to force bulk solid to slide along the walls. So if it is not steep, so it is in different design, then there may be chance to be funnel flow pattern can be generated, and not smooth to force bulk solid to slide along the walls. So if it is not smooth, then the same problem will be happening. It can also occur when the outlet of a bin is not fully effective. It's maybe because of the poor feeder or outlet design. Design is not poor. Design is not perfect. It is poor design. And there may be chance that funnel flow pattern can be generated. Funnel flow pattern means your flow can be generated in some funnel kind of structure, and then there are some stagnation zone is there where material get stuck. Initially, vertical channel of solid above the opening moves downward without disturbing the material at the sides. Okay, that's the thing. Material will move downward without disturbance of this side material, and then it will be converted into the what you can say stagnation zone. Then the lateral flow begins the first from the topmost layer of solid, and the lateral form is also just following them. So if you talk about the lateral flow, then you can understand the flow is going like this, and then this kind of is a stagnation zone or dead capacity which is always there, and then particular this lateral zone is also gradually going to this way only. And for designing of the equipment which can use the funnel flow pattern, we need to always consider diameter average high depth of the material, and that's some dynamic flow depth in funnel flow, theta and bottom aperture opening. All are the same thing, but here the configuration is totally different and the flow pattern is totally different than the mass flow. Now, what are the disadvantages? Obviously, there are some stagnation zone up here in between the apertures. So, mostly it has some disadvantages. What are those disadvantages? So called first in last out. So whatever the material which is first, as we see, so here, so whatever the material which we first fed, it is going there and stuck over there. It will not come out. It will come at the last only. So that is a very unsatisfactory pattern. Such material can aerate during discharge through flow channel, and this may give rise to flooding problems. So here some air pockets can be generated, and then it will go into flooding problems or uncontrolled discharge. There will be no control on the discharge over there. They are more prone to cause arcing of cohesive solid than mass flow beams, and they usually require larger outlets to dependent flow. They are producing arcs of the material, then it will require large outlet. Otherwise, in the small outlet, it is always going to stuck. It may cause segregation of solid and are unsuitable for solid that degrade with time. If our solid materials degrade with time, then we can't use it, as it can cause a solid segregation of the solid. Now, cleaner of funnel flow bin is often uncertain because solid in stagnant region may pack and cake. So, due to some materials stuck in the stagnation region, it is very difficult to clean out them. Funnel flow bins are suitable only for coarse material, free flowing or slightly cohesive or non-degrading solids. When our material is very economical, cheap, which has a coarse property, which is a easily free flowing property, which this kind of characteristics are there, then we can go for this kind of funnel flow. Flow of granular solids. Now there are two more topics into the second lecture, that flow of the granular solids and flow of the cohesive solids. So you need to understand what are the properties of the granular solids. So flow of granular solids to calculate opening depends on the diameter of opening and properties of solid. So whenever we are talking about the granular solids, we need to understand what is the opening, circular opening diameter is there, and properties of the solid are, what are the properties of solid, depends on, then it will be right. In general, it does not depend on the height of the bed of solid. Whatever amount of height is there, it does not depend on the model. So you can, it must be then independent in the size or the mass of the bed which is generated. Now for free flowing particle, the rate of solid flow approximately proportional to B cube. This is a B cube. You can consider this, where B is the diameter of the opening. So you can consider it as B raised to power B to the power of 3. In free flowing particle, we are considering the rate of solid flow is approximately proportional to B cube. So rate is proportional to B cube, and B cube is the diameter of opening. At the end, whatever opening is there, this is the B. Now flow of cohesive solid. The cohesive particles, we already know that weight particles which are interlocking, much more sticky particles are there. So they are very hard to flow. We understand that it is very difficult to flow the particles which are cohesive in nature. Columns of solid above the outlet moves out as a plug. It is always coming as a whole plug, not like individual particles, leaving a rat hole with nearly vertical slides. It will coming like slides only. Sticky solids and even some dry powders adhere strongly to vertical surfaces and have enough shear strength to support a plug of considerable diameter above the openings. If some material are sticky and some dry powder also have tendency to adhere, or you can say stick in the common language, with vertical surfaces, and then it will generate the shear stress, and then shear stress will support plugging of the material. Plugging for the plug of considerable diameter above the opening. Now, so for continuous flow of granular material or flow of cohesive material, we often following accessories are needed. Some vibrators are needed in our whole assembly. We need to attach some vibration instrument which can make the whole bean to vibrate after some amount of time. Internal plows near the bean floor, jets of air in the discharge opening. So you can put the jet air over here, and then internal plows also require sometimes you can use the internal plows in order to continue slow movement. Now we come to the last lecture discussion of this week, and from that we can able to solve some of example which is there in some of types of examples, similar kind of example which is there into the assignment problems. Now we are at our final stage where we convey our bulk solids. So for the conveying of the bulk solid in process industry, it will require additional cost. Obviously, we want to convey bulk solid from one place to another. It is required a huge amount of investment and capex, capital expenditure, operational expenditure from the industry to operate it and do some maintenance. So where it is required to additional cost from supply point to storing point between the stages during the operation, packing and distribution. Everywhere we need to transport storage solid from one place to another, or from one process to another process stage, or some packing distribution. So many types of conveying equipment include conveyors. We all know that many belt conveyors, chain conveyors, screw conveyors, elevators, bucket elevators, cranes, trucks, pneumatic systems. Many kind of equipment we are using to transport the solid from one place to another. Most of the material can be based on gravity or manual labor, or by employing power means. It can be based on the gravity. Sometimes we just use the gravitational force to transport them. Sometimes by using some man-made labor on employing power. Matter of motion provides the basis of subdividing these conveyors. Okay, so according to the which kind of motion you are providing, it will be subdivided this time conveyor. For bulk particulate or powder material, following classification of conveyors appropriate. So basically we just have to keep in our mind the basic for the particulate or powder material. We need to go for belt conveyors, chain conveyors. Chain conveyor has a different bucket elevators, apron conveyors, scraper conveyors, then screw conveyors and pneumatic conveyors. These four are the very major and very commercial, you can say, the types of conveyors for the conveying solid. Now we are just go for this small description of each of the conveyor, not all each, but mainly on which you might get some examples. So like belt conveyor, bucket elevator. So belt conveyors consist of an endless belt operating between two or more pulleys, friction driven at one end and carried on the idler drum at the opposite end. So it is like belt, sorry for my drive, which has some pulleys, so it is motion is going on like this. So you can consider any motion. I'm just like doing like this. You can I think most of the belt conveyor you can operate it on the either way, by left to right or right to left. Belt and its load have to be supported on idlers. Sometimes in between they are using idlers to support both conveying and returning section or the whole belt, because only belt we can't, if you have a high mass solid mass, then you can't sustain it. Used for solid conveying a distance of meters to kilometers. As belt conveyor used for the distance up to the kilometers. So as you can understand, this is a very well bulky system and it can be used for the large scale transportation. Now damage to solid in transport is slightly or negligible, as there is no relative motion between belt and solids. Solid transportation has a damage very slight or very negligible because there is no relative motion. Now carrying capacity is high. As you can see, there is a area is much more large. So area is large, that's why capacity of the conveying the material is also large. Now carrying solid long distance, mainly in horizontal plane. Sometimes it can be also inclined of 50 to 20 degree. To avoid spillage or runback, special blades with corrugated sidewalks and lateral ribs are used to steeper inclination up to 45 degrees. So whenever we require the steeper inclination, we use the corrugated sidewalks or some designing like that, so which is corrugated in nature, so we can't lose our material. But the main thing is the installation cost is high, and but we are going for the very long range, that's why cost is high. Now the power calculation of the belt conveyors, and there are examples based on this basic equations. There are many ways. If you can follow the textbooks, then you can derive these equations, that what are the power requirements, the power calculation, you can derive those equations from the book, you can go through that. But basically we have to just remember the equation, and that's why we don't need to go for much derivation and all. So that's why you can consider the direct equation from this. So horsepower, we are always getting about the motor horsepower, not it's in the power, it's a power unit only. 1 HP is equal to how much watt. This is your homework, or you already maybe everyone knows 746. So it's a big deal. Or but constant horsepower required for transport of solid by belt conveyor can be calculated by considering the frictional resistance. We need to consider the frictional resistance of belt, lift, different pulleys, trippers, everything, whatever is there which is associated with our belt conveyor, we need to consider the frictional resistance developed by that particular belt, that lift. We have pulleys and trippers, all of them. But constant use in such calculation may vary with change in operating conditions. Now these are some examples or some formulas which we need to consider for calculation. Power to drive empty conveyor, this is the equation we need to use. P equal to F L plus LO, L 0.06 W V 270. What is the value of, you can consider F is a friction factor which has a value of 0.03 to 0.05. P is a power which is given the value in the horsepower at the end. LO is a constant value which you will get in the examples. L is a conveyor length. W is a weight of moving parts, so conveyor in kilogram per meter overall length. Small v is the conveyor speed, or you can say velocity, or meter per minute. Then T is a conveyor capacity. H is equal to height of the lift, and Y and Z, some constants are there. Then power to convey materials on level, so this is a FL plus L naught T by 270. Power to lift material, you want to lift a material, and TH by 270. Power to operate the tripper, if you are using trippers also, then YV plus ZT. So Y and Z are constant. V is the velocity, T is the capacity in turn per hour. And according to your belt drive, if it has empty conveyor, obviously it has, then what is the level, if it is lift the material, operate the material, or it is in the level only. According to that, you need to find the power requirements in each and every operation, and at the end you need to sum all of the four quantities in order to calculate the belt conveyor with all these kind of power utilized. So example, what is the power requirement in, obviously horsepower to move the load of 875 tons per hour of a conveyor material. It's a conveyor material on a conveyor belt of 1.25 meter wide, this is a diameter, and 70 meter long. The conveyor operates at 90 meter per minute, and its moving parts are weight 7500 kg approximately. Constant F and L naught, which is always given, like 0.038, 0.29. So F is equal to always 0.03 and 0.05, in between them only. So how can we perform the calculation? So in the solution, we need to, here our conveyor material we need to convey, there is no mention of any lift, so we need to consider power to operate empty conveyor, what is the power requirement is that, and power to move load, or moving the load from one place to another. So this is the common equation which we use for the empty conveyor, and we have all values. Our F value is there, 0.038, L naught is there, 29, capacity in ton is there, so diameter is there, and length is there, then weight is there, W is there, and velocity is there, or you can say the speed is there. So but here our W is equal to 7500 kg, but we in our equation the value is weight of moving parts in kilogram per meter. So you don't need to, you always keep remember that you can't use directly whatever the amount of weight is there, you need to convert it into the kilogram per meter format. So that's why you need to just convert into the meter, 100 meters, so it's 75 kilogram per meter. V is equal to 90 meter per minute. Then you have to substitute the value in the equation, and at the end you will get the 5.643 HP horsepower is the value from this equation. So it's a very easy. Now this is, we only consider the empty conveyor. Now we will go for the moving the load. For movement of load, the another equation is that P equal to F L by L naught T by 270. So we just need to put the values, and then we will get some value of 12.19 HP. So now what is the amount of total power required? For that we will just sum the both the power, and at the end whatever the answer is there, which is our final answer. Okay, so this is a very common example. We just need to put the values in our predefined equations, which is the empirical mostly in the nature. So from this you can able to understand some assignment problems. So now we are going for the next conveyor, which is a chain conveyor. So chain conveyor has main components like chains obviously, then moving elements which are moving, and some drives. Okay, so this is the motor drive. So types of chains used in commonly are malleable detachable chain, malleable pintle kind of chain, steel and roller combination kind of chain. Now, so malleable detachable chain is the most common. So malleable chain, as you can see everywhere in the cycle, bicycle chain, everywhere you can get the malleable, which is easily detached also. Pintle chain characterized by a pin which has pins in between connect the link is useful like this, and we are using some pin. Vertical service such as a vertical elevator. Now depending upon how chain and moving element are mounted for a given duty, several types of conveyor can be obtained. From this chain conveyor have converted into the various different types of conveyors: scraper conveyor, apron conveyor, and bucket elevators. Now bucket elevator, why we are discussing that? Because it's important and it's a commonly available. There may be some questions is there if possible. So consists of high capacity units primarily for bulk elevation of relatively free flowing materials. As bucket elevator always has buckets, and it has high capacity. They are simplest and most dependable equipment for vertical lifting of granular material. Now available in wide range of capacity and high efficiency. They are always available in different kind of capacity, efficiency. Return leg may be rotated some distance from elevator leg. So important consideration why we are considered bucket elevators. So for design and operation purpose, if we talk about the these elevators, we need to consider the some properties of material, some space and shape and spacing of the buckets. How can we shape and space the buckets? Speed at which the elevator is driven, method of loading the elevator, method of discharging the elevator. So all these things you need to understand when we are design the bucket elevator for the particular operation. Now method of loading bucket elevators are three different ways. So as I just want to, as you can see, there are three different ways. Space buckets receive part of the charge directly from the chute and part by scooping. So there are some spacing in between. The space buckets are there. They are known like this. So it is some part is charged directly here, and from between some chutes also they are getting some charge. Continuous buckets are filled as they pass through a loading leg and with feed spout about the tail wheel. So this is a continuous bucket. They are always fed with loading leg whenever they are in between near to the feed spot. They can also be loaded in the bottom just put. Method of discharging of bucket elevators. Space bucket, centrifugal discharge elevator. These are used like space bucket and they are centrifugally discharged by with the help of centrifugal motion. Space buckets, positive discharge. These are the positive discharge. With the help of positive discharge, whole bucket will be come into the condition where the material will be discharged. Another is the continuous bucket elevator. Continuous bucket elevator has very smooth continuous operation and the efficiency is also much higher. Now bucket with a horsepower, which is very easy. There are for space bucket you need to consider power is equal to ton per hour capacity into h and divided by 152. H is the height. Lifts, h is the lift in meters or height in the meter. For continuous bucket you have to consider p is equal to th divided by 167. That's it. Go above for space bucket 152. These are the empirical equation. So if you want to learn more about it, you can go to the reference books. So both equations include normal drive losses as well as loading pickup losses and applicable for vertical slightly inclined lifts. These two small easy equations include all the pickup losses, drive losses and any applicable losses for vertical and inclined lifts. Now this we are going for the example. So a measure of 235 ton per hour, this is a capacity of calcium carbonate, is to be transported to a processing plant of 25 meter. We need to transport about 25 meter above its storing place. A belt conveyor is selected for this duty with maximum slope of the 35 degree. So belt conveyor has a slope of 35 degree. Moving parts weight of belt conveyor is 1770 kg and the velocity of conveyor is 36 meter per minute. Constant F and L naught have been evaluated as 0.027 and 33.2. So respectively, what is the total power required? Now we know this height, but we don't have the don't know the length of our bucket elevator or our belt conveyor. So we need to check find the length of the belt conveyor. For that we can use a simple right angle formula for the triangle. So here we know the value of this, we know the value of this. We want to find this, so we can go for the sine. So here a solid material is like that. We need to transport it from one place to another, and we have the value of 25 meter, 35 degrees there. So we don't have the value of this, but obviously by using the sine 35 we can get the value of 25 by L. So at 10 you will get the value of length of material. So length of conveyor is very easy. Sine 35, 25 by L equals 43.6 meter. So total length is 43.6 meter. And weight is, for weight we need to consider what is the amount of belt conveyor, weight of belt conveyor 1770 kg and divided by the length. So per meter what is the length? 43.6. Now for empty conveyor we have the same equation. F equal L plus L naught 0.06 WV by 270. We just have to put the values. All the values are there in the equations. L naught, F, total length we just find out, weight we find out, motion mass per meter per second, speed meter per second. Got the P value 0.673 HP. Power to lift the load. Now here we have to lift the load at some from here to here. That's why we require to use the P equal to TH by 270 equation. And at the end you found that total power requires 22.43 HP. So these are some things. Now if we just replace the same belt conveyor with a bucket elevator, because bucket elevator mostly we are using bucket elevator to transport the material from one place to some elevated place. So that's why if you are going to use bucket elevator, then what is the power requirement in HP? So there are two different types of bucket elevator. One is a one is a space bucket elevator, and another is a continuous bucket elevator. So you can use for the space bucket elevator P equal to TH by 152. You just have to put the values and you will get the value of power 38.65 HP horsepower. For the transportation of continuous bucket elevator I use, then the TH by 167, then 35.18 HP. Now as it is almost 8 o'clock and So all 1 hour is over. So these are some same books which we are using, and some of the good discussion is given in the Ortega Rivas book as unit operation of particle solids. Then McCabe Smith, which is the unit operation of chemical engineering. Then question analysis and volume, and some Genco Police transport processing unit operation, and there are some few books you can go through that. But if you find measure of the topic on the first and second book for the today's discussion. Now at the end of the discussion, I want to thank you all for listening these recordings, or because unfortunately I don't have any idea that any student was there in the live session throughout. And I want to give you have to spare some time in this kind of session. That's why only you can rebrush your knowledge. Only 1 hour is required to rebrush all whole week of knowledge, and you can get many insights of solving examples. That is too much important. And the important thing is to never stop questioning. I always believe in this, that you have to always ask the questions. This is my email ID. You can anytime drop an email to me regarding this subject. If you don't find anything which is there, you can't understand and don't find comfortable to afford any explanation, if you want to go for more discussion, more deeper discussion, anything. And I want to thank you all. Like this we can just okay, stop sharing. So at the end, I want to thank you all. Keep doing the hard work, and all the very best for your future. And yeah, if you have any question, you can drop me an email anytime. Bye.